The last 2 months of progress in Electrunk can be summed up pretty easily. You can place blocks now. And while the end result is nothing to write home about, the amount of time and energy it took to get this little test block onto the screen would surprise you. So in this devlog, we're going to get deep into some code. I'm going to show you the guts and you're going to judge how bad it is. My entire goal for this video was to get the building system up and running in the new sprite stacked format. Unfortunately, the engine required quite a few upgrades to make placing this little guy happen, including a new inventory and UI system, an event manager, an all new way to create items and crafting recipes, and even a runtime generated texture atlas. If you're new here, hi, welcome. I'm making a survival crafting tower defense game. I think the best way to conceptualize it is if you take Terraria or Core Keeper and then made the main gameplay loop a tower defense, but you have to actually gather the resources to craft the towers instead of just buying them from a shop. The game is written from scratch in Zig and uses Rayleigh but OpenGL for rendering. As of right now, there are no other dependencies. With the goal in mind to implement building in the new engine, I took a look around at the current game. I had a character, some simple terrain generation, and an all-new fake dimension to explore. If I was going to be placing blocks down, however, I would need a couple of things first, like a block to place, an item, if you will, and I would need somewhere for the player to get the item from to place, like their hotbar or an inventory. Now, technically, I already had the hotbar and inventory in the game, but as it turns out, that code was trash and was incompatible with the new and improved ECS version of the engine. The old version of an item was very straightforward. It was essentially just a struct with some data like an ID, a name, some damage types, but this struct was incompatible with the ECS, which expects an entity and some components attached to said entity. So my first task was to create a representation of an item inside the ECS. How do we do that? With the complex web of components, IDs, and systems. My initial goal here was simply to get an item rendering in the hotbar. I set up a couple of important components, namely an inventory component, which will allow me to give an entity an inventory. This is useful if I want to store things in a chest, an NPC, an enemy, anything really. Any entity can have an inventory component. For instance, the mouse actually has an inventory as well with a capacity of 1. Inside the inventory component, we have a list of the actual entities inside the inventory, as well as a list of the UI elements they are attached to for rendering. Now I had a way to actually begin to render these items, but I needed the hotbar and inventories I already had to render these new versions of items, basically entities with components. Except I forgot one crucial detail. UI is a complete hellscape, even when you're using a library, which I have not. I remember not wanting to work on this project for the entire last 2 weeks of April, just because I knew I was going to have to do more UI work. Not to mention, the last version of the UI was already a rework, so now this was a rework of a rework. Regardless, I'm no pussy, so I buckled down and eventually cobbled together a system that allows me to create new menus with some useful things like padding components, sizes, invisible boxes, hover sprites, and more. The basic things you might expect a UI to have. I then strung this mess together in a system that renders the UI, and another one that updates the position based on the current size of the window so that when you go full screen, the UI menus move appropriately. And then I was finally able to see my item in the inventory, only it couldn't do much at this point. And next I had to implement the actual functionality of the inventory. I had to be able to move items and split stacks. Moving items was simple enough. We take the item from the inventory, put it in the mouse's inventory that I mentioned earlier while it's being dragged, then place it into whatever slot it's hovering over when the mouse button is released. That was the easy part. The hard part, well, the hard part involved a lot of generics. Splitting item stacks is expected behavior in crafting games. It's a very useful feature to have to move items around. I wanted the player to be able to right click and split a stack of items in the inventory or hotbar in two and be able to move them around like that. In the old engine, this was very easy. We had the item data from the struct, we had an amount, we simply copy the struct and set the count in the inventory to half of what it was, and then put half on our mouse. Pretty easy. But now, well, now we have entities, and entities have no data. The components have the data. But how exactly do we split an entity or a component? You can't have half an entity. So what's the solution? A clone. We create a new entity on the mouse and clone all of the components from the inventory to the new entity. But how exactly does that work? If you're taking a clone of the components from an entity, you first need to gather a list of all the components an entity has. This is fairly simple as each entity has a component mask, so we just copy over that data to the new entity. But what about the data associated with that entity? This is where the tricky part comes in. We need a way to go from component bit, find the data associated with our entity, and then copy it to our new entity. Each component is controlled by its own manager. The transform component is managed by the transform manager, the sprite component by the sprite manager, and so on. Each of these managers keeps track of which entities have which components. So to query if an entity has a component, we can use the respective manager. Each manager, though, is a different type under the hood. They all share the same interface to make interacting with them easier, but under the hood, they are still treated as different types. So it's not as simple as being able to map an entity to their component storage. We need something called a generic. Now, different languages all have different ways of doing generics. In Zig, I do not understand them at all. This is probably why this problem took me like 3 days to finally nail down. In Zig, the correct way to do this is with something called a vtable. It involves essentially creating a wrapper with a type erased pointer and then passing in the type we need to cast the pointer into, which makes a lot of sense in retrospect, but trying to figure this out on my own was very, very confusing. AI and Google have been going down some weird rabbit holes. Once we pass the correct type, Zig knows how to create our function at comp time, and we can essentially cast our manager type when we clone a component bit. We just have to map the U32 bit to this wrapper instead of the storage or manager directly. After that catastrophe was over, I was left with my next task. I now had a semi-working inventory system, but I still needed some more structure in the engine. Something was missing. The ECS was still incomplete. I needed something that would tie everything together. One of the core tenets of an ECS, or at least in my case, is the separation of concerns. Every system that does something does only one thing. If it's an update system, it just updates that part of the code. If it's a rendering system for sprites, it just renders the sprites. This is nice when the game is still small, and also scales really well as the game grows in complexity. Everything can hook into existing systems provided it has the right components. However, this leaves you with another problem. Let's say you're in the inventory and you want to drop an item on the floor. How does that work? Do you now hook at the code to drop an item on the floor to your inventory system? Well, you could, but as you start making more exceptions, you end up with a huge mess of systems together. One way a lot of ECS implementations handle this issue is with an event manager. The event manager lives in the ECS and acts as a way for systems to talk to each other. This is usually done via a pub submodel, but I think there are also other ways of doing this as well. The way it works in my engine is pretty simple. We have an event writer that fires off events. This allows us to separate the logic from the system. We simply fire up an event in our event inventory system and then listen for it or subscribe to it in our inventory drop system. That way we keep our clean separation of concerns, but are still able to communicate across systems. If you're familiar with Godot's signals, these are kind of like that, but instead of nodes, it's functions. Now, I could feel I was getting close. There were still a few upgrades I wanted to do while I was working on items. In the last iteration of this engine, I opted to create my items directly in the code. This works well at first, but as the item count scaled and it grew more complex with crafting recipes and other things, I was left wishing that I hadn't. So when the opportunity to rework this came up, well, I decided to go with the classic JSON item table. Well, first we do it in a Google Sheets doc, then export it as a CSV, then we run a custom script, and then convert it all to our final JSON. And then from there, we load the JSON into the game. This makes it really easy to add new items and struct fields as well as edit existing ones, and it's much easier to keep track of. But as a reminder, this data is decoupled from our actual entities aside from the item component that just keeps track of our item ID. So once we have these items in the game, how do we actually get the data associated with them? Well, for most of our test items, these are already components on our entities, so we can just get their associated sprites and texture data. But when I wanted to start the building system, I had no way to go from the entity ID to its associated texture without assigning this at entity creation, which just wouldn't be the case for all entities in the game. We needed a way to go from an entity, check if it has an item component, and then getting any data about the item ID attached to said entity. This is where the concept of a resource comes in, along with the appropriately named resource manager. A resource in an ECS is a way to keep track of some global data that exists outside of the ECS. Basically, if it's not an entity, a component, or a system, it's probably a resource. This is a great place for us to register all of our items from our JSON parser and map our item IDs to the rest of our actual item data. But not only did I do that, I also took the opportunity to go from individual textures and images to a texture atlas. And not just any texture atlas, but one that is generated for me at runtime along with the UVs so I can grab any texture I want from the atlas without having to go through and calculate these myself. I first tried doing this using the skyline algorithm, but that was way too complicated for me to understand, and not only that, but I think it was overkill for my use case. It also didn't work super well with my sprite stacked images. These stacks are taller than they are wide, and I think that doesn't really work well with the skyline algorithm. To compensate for these horizontally challenged images, I ended up writing my own algorithm, which is like a modified version of the shelf packing algorithm. I first sort all of my textures based on their width and then place them into a larger texture, checking if there's space below them to pack another texture. If there is, we place it there, and if there isn't, we simply start another column and continue from there. This does leave a lot of empty space, but since our textures are only one of a few different widths already, this makes it very simple to stack them vertically. As I get more assets into the game, I will probably have to refactor this, but this is plenty good for now. Once all that prerequisite work was finally done, I was able to begin the building, which compared to everything else, actually went fairly quickly. I had already implemented a basic line algorithm called Bresenham's line algorithm for the previous version of tile-based placements, so it was pretty simple enough to copy this over. What wasn't simple, however, was where to store this data. The system is run every frame, so we can't store it in there, as it would just be overwritten every frame with new data. This is a perfect place for a resource, but what kind of resource? Well, as it turns out, I simply stored the placement positions as just an array of vector 2s and then reused the buffer as needed, clearing it after the player is done drawing. This has the added benefit of being very simple to initialize and a very low memory cost. When the player holds down the shift button, they see a preview of the block they're going to place. Then, when they hold down right click, we start storing the tile locations that the mouse is on. These are placed in the buffer. After the player is done drawing and right click is released, we listen for this event, then iterate over our current buffer, creating new entities at the locations stored in the buffer. This was great, but now I wanted these ghost blocks to be placed as well, so I did the same thing using a different buffer for the ghost blocks, turning them blue to indicate this is a preview of blocks. Eventually these will be color coded, so if a placement is invalid, the block will be red, or if you run out of blocks, it will also turn red, just like in the previous version. The player can place up to 32 blocks at the moment, which is just the size of the block buffer. When the right click event is fired, we just create a bunch of the entities at those stored vector 2 locations and give them the same components. I do this with something called a factory, which is just a way to initialize a bunch of entities with the same core components. This is a fairly common concept in an ECS, or so I've heard. With the correct components attached, the entities are automatically picked up by our render system and drawn right into the game with no extra work needed. The next problem is obviously performance issues. As you can see here, placing like 100 stacks absolutely destroys our performance. I have a few ideas on how to fix this, mostly sending them to GPU, but I reckon this will be for another time. There are also some rendering issues and depth sorting problems still, but I'm not too worried about these. I think that when I get to doing collisions, I'll also fix the depth sorting problems. I've done a lot of back-end work for this video off screen, so I apologize for the lack of interesting clips. Most of it was just slogging through the development. I wish I had more time to dedicate to this project, and I really enjoy seeing it come together. If you enjoyed the video, make sure to leave a like and subscribe. There is no wishlist page out currently, but you're free to join the Discord where I post semi-regular updates on progress and things I'm working on, usually at the rate of one every few days. Thanks for watching. The next big hurdle is going to be collisions, like I talked about earlier, and then I want to get resource gathering back in the game, as well as an experiment I have with some IK and procedural animation. So subscribe if you don't want to miss that video, and I will see you in the next one. Thanks for watching.